Hello and welcome. Today I'm going to write a binary to decimal converter using three different programming languages and really taking three different approaches to the same thing. And I'm going to be using Python, JavaScript, and Haskell. And we're just going to see how each language is doing. So a binary to decimal converter, first of all, just a quick explanation about how to count in binary. So when you see a binary number like 0011, this is a 4-bit binary number. What you're basically doing is you're starting from right to left. You take the bit, or you take the number, which can be either 1 or 0, and you multiply it by 2 to the power of its index. So it doesn't really matter if you start from left to right or right to left. It just the index is very important because it's kind of equivalent to like the carrying of the 1. So basically what you're doing is, for example, we have this 0011. So if you take the first number from the right and you apply this, so you say basically 1, so the bit times 2 to the power of its index, which is 0. We're starting from 0, okay? Starting from 0. So 2 to the power of 0 is 1. So 1 times 1 is 1. And then you carry on. So you take this 1. So 1 times 2 to the power of 1. 2 to the power of 1 is 2. So 1 times 2 is 2. Okay, sorry about that. And 0, so you have like 2 to the power of 2, which is 4 times 0, it's 0. So whenever you have a 0, you can basically cancel this out because it's a 0. So 2 plus 1 is 3. So this is how you count in binary. And this is what we're gonna do. And in some implementations, I'm going to count from right to left. Some of them I'm going to use from left to right. So it really depends on how I'm going to approach this problem. So I'm going to start with Python. And just to be clear, Python comes with a binary to decimal converter out of the box. So if you do like if you write a binary number, start from 0b, and then like let's say write this, you get 3. Okay, but this is not the purpose of this video. So what I want to do is I want to build a function that gets a number in a form of string like this, and basically returns an integer. Okay, so we're going to start with defining a function called b2dec, which is binary to decimal, and it takes a string, which is this is the actual number that we want to convert. And the first thing that I want to do in Python is I want to reverse the order. So I'm going to do something like that. But also, I want to also convert this reversed version to a list of integers. Okay, so it will be much more useful. So what we can do is we can enclose it with this list brackets, and we can use something which I love. It's called the list comprehensions. So we can do we can cast each element to be an int for x in a reversed version of this string. So this will gives us a reversed version of the number and in the form of integers. So it's pretty cool. And let's just declare y is an accumulator which starts from 0, and we're gonna do a loop, and we're going to iterate over an index. This is because we want to use the indices, okay, as our power of 2. So I think the best way we can do it is to use the range. So for I in range from 0 to the length of our number. And what we're gonna do is simply say that this is number at I, which is the bit, so it can be either 0 or 1, times 2 to the power of I, okay, 2 to the power of its index. And I think it's pretty straightforward. And there we go. So this is the function to convert binary numbers into a decimal. So let's try to run it. So let's go with Python and let's load up this file. So index.python. There you go. Yeah, read. Okay, so b to dec, if we passing this, we should get 3, and we do. And if we pass a 4-bit number all with ones, it should be 15. Okay, and an 8-bit number all with ones, I think it's 8, 255, which is correct. So this is the Pythonic way of doing this. Let's move on to the JavaScript way. So what I'm going to do with JavaScript, I'm going to start with export it as a module, and this is because I want to play with this in Node in the terminal. So we're taking a string, and so unlike Python, strings in JavaScript are not arrays or not lists. Okay, they do share some similarities, and you can reach them like with indices, and you can do a lot of things that are similar to arrays, but some of the things are not applied to strings. So the first thing that we're going to do is we're going to convert this string to an array by calling split. Okay, and we can call the split with empty string, which will take each element and basically break it apart and make just one element out of string, out of an array. Sorry. So the next thing that I want to do is to reverse. So reverse. There you go. Is to reverse the array. Okay, like Python, and also like Python, I want to convert each element to an integer. So right now, each element is a character, is a string. So I want to convert it to an integer, and I can call parse int with this element. And funny enough, it's going to be in the base 10 because we want 0 to be 0 and 1 to be 1. So it's kind of funny. And lastly, I'm going to use reduce. And reduce is a very, very powerful function in JavaScript because you can get everything from reduce. So you have the accumulator built in right into the function, and then you have the element, and then you have the index. So in Python, we had to do some stuff, to get each one of them, like the index and the elements and the accumulator. But in reduce, we can actually get everything within the function. So we can add to the accumulator x, which can be either 1 or 0, times, and JavaScript doesn't have the built-in power operator in JavaScript should be important from the math library, 2 to the power of I. So I think we are ready. So let's fire up Node, and let's bring this. Okay, so let's see if it works. Should be 3, and we're getting 3. And let's see if we're getting 15, and we do. And an 8-bit or a byte should be 255. So it works really well, and as you can see, it's a little bit different than the Pythonic way. So the Pythonic way is kind of is much more imperative. So it prepare a lot of like steps, and the JavaScript is a little more declarative, so we can kind of see what we're doing. Okay, we're saying in words what we're doing. We're splitting, we're reversing, we're mapping each element to an int, and then we're reducing all of the elements with this equation. Okay, so this expression, sorry. Okay, so let's move to Haskell. So in Haskell, things are getting very interesting. So, and if you're not very familiar with like pure functional programming languages, the next thing that I'm gonna do is gonna look a little bit weird. So I'm gonna take the function, so b to dec, binary to decimal, and do something like this. So what I did now is I actually defined that whenever this function receives in its argument an empty array or an empty list, it will simply output 0. So this is the actual definition. So in functional programming, you can actually define your function multiple times. So it can seem a little bit weird because in languages like JavaScript and Python, the entire logic of the function should be within the block of the function, within the scope of the function, right? So so everything should be inside the function. And in Haskell, you can define the function in multiple times. It's actually called pattern matching, so you can match different patterns. So one pattern is what happens when an empty list is coming in, so it will just output 0. And then I'm going to write the function first, show you that it works, and then I'm going to explain a few things. So let's start. And we are done. So these 2 lines are actually representing the entire logic and functionality of converting a binary number into a decimal. So let's fire up GHCI, which is the kind of like the interpreter of Haskell, and let's load up this file. So index Haskell, and let's see if it works. So let's pass in the string. We should get 3, and we are, and should get 15 here. And we do, and 1 2 3 4 1 2 3 4. So an 8-bit, a byte of just once should be 255, and it is. So what is going on here? If you're not familiar with Haskell, this can seem a little bit weird. So first of all, it's completely optional, but this is a good practice in Haskell to actually write the signature of the function. So it takes a string and returns an integer. Okay, now a string, by the way, in Haskell is just a fancier name of writing an array of characters. All right, type char, whatever you want to call it. And this weird thing, so Haskell implements its lists as a linked list. So basically what you're seeing here is the head of the list and the tail, the rest of the list. And with this operator, this colon operator is the constructor of lists. So what does it mean? So it means that this one, for example, is exactly the same as doing this. Okay, and if you put like another number here at the head and with the constructor, you get exactly this. Okay, so really an array of characters which can represent by doing this double quotes. So let's say this array of characters, it really is just a list of characters that looks like this, representing in a single quote. Okay, and you can also write it down like this. So these 3 versions are exactly the same. Okay, but what's cool about it is that when you use this notation of using the constructor, you can actually deconstruct the head from the rest of the list. So what you're seeing here, this is the head of the list, and this is the rest of the list. So it's the entire list minus the first element. Okay, so let me show you how the recursion works here. So if we're calling b to dec with this string, so what's really happened is first we're calling a function called read, and we're taking this first element of the list, this 0, and the reason I surrounded this with brackets is because this read function takes a string, which is an array of characters, and the x is just 1 character, so we need an array, and it turns it into an integer. So this read 0 will eventually become just 0 as an integer, and then we're doing times 2 to the power of the length of x's, which is the length of what remained here, okay, which is 3. And what's cool about this operation is that the length is actually proportional to the index of the number that we're talking about. So it's actually we're kind of using the shrinking length as our index. So 2 to the power 3 is 8, but times 0 is just 0, and the entire thing is plus b to dec with the rest of the array, the rest of the list. So now we're going to do another one of these because we're calling it again, but now it's going to be with 1 one character less, and it's still going to be 0 because it's 0, and whenever we have a 0, it will be 0. And then we have 1 times 2 to the power of the length of just this, so the length of 1, which is 2, so 1 times 2 is 2, and here we have just the last character. And then we have 1 times 2 to the power of the length of nothing, of 0, so it's basically 2 to the power of 0 is 1, so 1 times 1 is 1, and this is an empty array, so we can also write it down like this. And we said that whenever we pass an empty array, it's going to be evaluated as 0, so this entire thing will be evaluated as 0, which means that 1 plus 0, this entire thing will be evaluated as 1, which means that this entire thing will be evaluated as 2 plus 1, which is 3, and 0 plus 3 is going to be evaluated as 3, and again 0 plus 3 is going to be evaluated as 3. So there you have it. So we got 3, we got the right number just by doing this recursive function. So I hope you like this video, and if you like this video, please subscribe for more, and thank you for watching. See you next time. Bye bye.